So good morning friends. Actually due to some technical problem I couldn't start in time. Okay. In the previous class we have learned some of the problems from inequalities, but after that I came to know that it is not in our half yearly syllabus. So I have to go to the next, that is plane geometry. Plane geometry class 9 advanced maths. Okay, plane geometry. Okay, this is chapter 7. Okay, this is chapter 7. We are going to discuss some other things from here. Okay, I try to complete the concept of this part. So my dear, here we have to discuss about a triangle and its medians, altitudes, angle bisectors and perpendicular bisector of the sides. Okay, in a triangle, if I take a scalene triangle ABC, okay, the line segment comes from the vertex. The line segment comes from the vertex to divide the opposite side. That means it will fall exactly in the midpoint of the opposite side. Suppose D, then this is called median. Then this is median. Okay, that means median comes from the opposite vertex to divide the opposite side. That means this D will be the midpoint. This D is the midpoint of this triangle, of this BC side. Okay. Sir, this one is disturbing me. Okay, so median means it falls on the midpoint of the opposite side. Okay, here we will get BD is equal to DC. Okay, in the same case, if you draw a perpendicular in the same triangle, if you draw a perpendicular, then this perpendicular is called the altitude. This is altitude. So the first point is median, second one is altitude. Altitude is the perpendicular from the opposite vertex to the opposite side. That is its altitude. Okay, altitude means this A, suppose E, this AE is perpendicular to BC. AE is perpendicular to BC. Okay, this is altitude. Then another one, if you draw a line segment which divides this vertical angle, that means this angle is equal to this angle, these two angles are equal, then it is called angle bisector or internal angle bisector of this vertical angle. So this is angle bisector. So this one is angle bisector. Okay, and then another triangle I will draw. And then if in this triangle ABC, if a line perpendicularly bisect a side, then it is perpendicular bisector of the side. So here also we will have perpendicular bisector of sides. For this side also perpendicular bisector of sides. So perpendicular bisector of sides means it may not go to the vertical angle. Okay, so it is perpendicular as well as it bisects the opposite side. Okay, now you should not be in confused between altitude and perpendicular bisector of the side. Perpendicular bisector of side, okay, is perpendicular to the side and which will bisect the side in equal two parts. Okay, here also in altitude it's perpendicular to the opposite side, but it will not bisect the opposite side. Okay, this is not a midpoint and it is always comes from the vertex. but here it is not necessary that it will always comes from the vertex. Okay, so perpendicular bisectors, these are the perpendicular bisectors of sides. Perpendicular bisectors of side. So my dear, median means the line segments drawn from the vertex to the midpoint of the opposite side is the median. Median divides the opposite side into equal two parts, that is that much only for median. Now altitude is always perpendicular to the opposite side from the vertex, that is altitude. Angle bisector, which will bisect that angle, that vertical angle into equal two parts. And then perpendicular bisector of side, the line segment which perpendicularly bisects the side, no matter from where it comes, but the line segment always bisect the sides perpendicularly. Okay, these 4 points we have understood. Okay, so can I wrap this one? So the first, these 4 lines I will write in order. Okay, so first we have got here, first one is median, okay, and then the second one altitude, okay, the third one angle bisector, okay, fourth one perpendicular bisector of sides, okay, perpendicular bisector of sides. Okay, now when these median, altitude, angle bisector and perpendicular bisector of sides meet inside a triangle, within the triangle, then what are the points, what are the results we will get? In this triangle ABC, if this is a median and we can draw other two medians, okay, this one and this one, okay, through vertex A one median, through vertex B another one, and through vertex C another median. We have drawn the three medians. Okay, suppose AD, BE and CF. Now the meeting point of the median, it's called, the meeting point of the median, it's called centroid and it is denoted by G. It is called what? Centroid. So the meeting point of median is centroid. That means when these three medians meet within the triangle, then this point is called centroid. Now this centroid always divides the median in the ratio 2:1. That means if AD is the median and G is the centroid, then AG is to GD, that is AG is to GD is equal to 2:1. In other way you can understand, this AG is this is the two part and this is one part. That's why AG is equal to 2/3 part of the total AD. Similarly, GD is equal to 1/3 of the AD, whole median. AG is 2/3 of the median and GD is the 1/3 of the median, it is AD. Okay. Similarly, this BG is 2/3 of BE and BE is 1/3 of BE. Okay. Similarly, this CG is 2/3 of CF and GF is 1/3 of CF. Okay. Yes, that means centroid is the meeting point of three medians and it will always divide the median in the ratio 2:1. Okay. Next point, angle bisect altitude. Next point is altitude. So centroid always divides in the ratio 2:1. Just I have written the point to remember. Altitude. Now altitudes of a triangle. In this triangle ABC, if this AD is perpendicular to BC, then BE is perpendicular to AC and CF is perpendicular to AB, then the meeting point of this altitude, O, okay, is called orthocenter. It is called orthocenter. Okay, that means the meeting point of altitudes of a triangle is called orthocenter. Okay. Here you will not get any other relation. Okay. Next point, these altitudes meet, then we will get orthocenter. Okay. The third one is angle bisector. The third one is angle bisector. Then in a triangle, in this triangle, suppose this is angle A, this is B, this one C, and if AD is the angle bisector, that means this AD bisect this angle A. If AD bisects this angle A, then this angle is equal to this angle. Is it? Bisects this angle A, then this one, these two are equal, these two equal. Now, in this angle bisector, if AD is the angle bisector, then what will happen? Angle bisector of an angle always divides the opposite side in the ratio of other two sides. That means if AD is the angle bisector of angle A, then AD will divide BC in the ratio of other two sides. What it means? You check, we will get BD is to DC is equal to AB is to AC, or we can write as fraction also, BD by DC is equal to AB by AC. Angle bisector always divides the opposite side in the ratio of other two sides. If AD is the angle bisector of angle A, then BD by DC is equal to AB by AC. Okay? Yes? Okay. Here are some problems. Here you face some problem. Okay. As I have started from BD, then my sides will be AB. If I start from suppose AC by AC, if I start from DC, CD, suppose CD by BD, then AC by AB. That means the sides will be along the part which we will take at first. Is it? This one DC by BD, then AC by AB. Same thing. Or suppose BD by DC is equal to AB by AC. Okay? This is angle bisector. Now, when this angle bisector, three angle bisectors from here and then from here, if these three bisectors meet at a point here, angle bisector meet within the triangle, then this meeting point is called in center. It is denoted by I. This is in center. It is denoted by I. Okay. Yes, yes, once again the meeting point of the angle bisectors within the circle, within the triangle, it's called in center. Okay, now if you take I as center and this ID or IE or IF as radius, then we can draw a circle, within the triangle, passing through these 3 points E, F and D. That means, my dear, in this case this IE is equal to ID is equal to IF. Okay, this circle is called in circle and these radii ID, IE and IF, they are called in radius. Okay, so in circle can be drawn taking in center as center and ID, IE, IF as radii, and this circle is called in circle and the radius is called in radius. This is all about angle bisector of a triangle. Okay, so angle bisector, what are the points you have learned in angle bisector? First we have learned that, okay, angle bisector of an angle of a triangle divides it in the ratio of other two sides. Okay, and then again what we have learned, and here what we have got, one more point, in center the meeting point, then we will get in radius here and in circle. Okay, so this is all about angle bisector of an angle of a triangle. Okay, the fourth point is, my dear, the fourth point is perpendicular bisector of sides. Perpendicular bisectors of sides. Okay, as we have understood, in this triangle ABC, okay, if this is the perpendicular bisector of BC, this is the perpendicular bisector of AB, and this is perpendicular bisector of AC. Okay, when these 3 points meet at a point, okay, then this point is called, this is meeting point of perpendicular bisector of side, is called circumcenter. This is called circumcenter. That means the meeting point of 3 perpendicular bisectors of side is called circumcenter. Okay, that is circumcenter. Now this circumcenter is equidistant from the 3 vertices. This circumcenter is always equidistant from the 3 vertices. That means this one or this one or this one. Is it? That means OA. Suppose this is circumcenter, then suppose this is O, denoted by O. Then OA, OB and OC are equal. OA, OB and OC are equal. Circumcenter is equidistant from the 3 vertices. That means, my dear, by taking circumcenter is radius, we can draw a circle which will pass through the 3 vertices. That means, taking this center and OA, OB, OC as radii, we can draw a circle which will pass through we can draw a circle which will, okay, this is not exactly the circle, you, okay, excuse me for that. Okay, that means we can draw a circle, passing through the three vertices A, B and C through this circumcenter, okay, and this circle is called circumcircle, and the radii OA, OB and OC are called circumradius. Okay, so from here we have understood the perpendicular bisectors of side. Okay, when they meet, then we'll get the point of meeting is circumcenter. Okay, then circumradius and then circumcircle. Okay, the these points, 4 points I have completed. Yes, again, once again, meeting point of medians or centroid, it divides the median in the ratio 2:1. Okay, meeting point of altitude is orthocenter. Okay, meeting point of angle bisector is in center. Okay, taking in center as center, we can draw a circle which is called in circle and the radius is called in radius. Okay, now meeting point of perpendicular bisectors of side is called circumcenter, and taking circumcenter we can draw a circle which will pass through the 3 vertices, and that circle is known as circumcircle and the radius is circumradius. Completed. Now, as I said, in every case is meeting point of, okay, then we will have to go for one more concept. I was thinking I cannot complete within the class, but still I have some time, then I will go for the previous concept. Okay, check here. When concurrent lines is supposed to be the first point. Concurrent lines. Okay. When two lines intersect, then they are called intersecting lines. These two lines intersect, then they are called intersecting lines, and this point is called point of intersection. Now, more than two lines intersect at a point, more than two lines intersect at a point, or more than two lines meet at a point, then these are called concurrent lines. They are called concurrent lines, and this point is called point of concurrence. That means when two lines meet at a point, we know that these two are intersecting lines, okay, or they intersect at a point, intersected lines, and the point at which they will intersect, that is called point of intersection. Similarly, in this case, if more than two lines, okay, 3 and more, okay, this point is point of concurrence. And these lines are called concurrent lines. Okay, so these point at which these three perpendicular bisectors of side meet, this is the point of concurrence. So point of concurrence of perpendicular bisector of side is circumcenter. Point of concurrence of medians is centroid. Point of concurrence of altitudes is orthocenter, and then point of concurrence of angle bisector is in center. Okay, this concept is also clear. Now another one, next point is Petal triangle. Okay, petal triangle. In a triangle ABC, if these three are the altitudes, means perpendiculars. Okay. Now, when we join the foot of the altitudes, these are the three foots. This is D, E, and F. When you join the foot of the altitudes, then one triangle will obtained. Okay, and this triangle is called petal triangle. If it is an equilateral triangle, this petal triangle also will be the equilateral triangle. If this is an isosceles triangle, the petal triangle will also be an isosceles triangle. What is petal triangle? The triangle obtained by joining the foots of the altitudes is called a petal triangle. Okay, petal triangle. For an equilateral triangle, the petal triangle is also equilateral. Of an isosceles triangle, the petal triangle is also isosceles. And the point is, in an isosceles triangle, ABC, this AB and AC are equal. Then from this vertex A, if I draw a median, then this median will be the altitude as well as it is angle bisector as well as it is perpendicular bisector of the side. Okay, that means when you draw an altitude in this isosceles triangle, now I am saying altitude, then this altitude will be the median as well as it will be the angle bisector of angle A in case of isosceles triangle. Only one this median, okay, which will be in between the two equal sides. Now, in an equilateral triangle, the same concept. In an equilateral triangle, suppose in this equilateral triangle, suppose this is an equilateral triangle, suppose XYZ. Okay, this is the median, this is another median, this is another median. Okay, the three medians are also the altitude as well as they are the angle bisector of the vertical angle. Okay, that means in an equilateral triangle, median, altitude and angle bisector coincide, when they are same. In an equilateral triangle, medians, altitudes and angle bisector are coincide. Okay, that means in this condition, for this equilateral triangle, centroid, orthocenter and incenter are always coincide. Okay, I hope you have understood all the concept, all the points I described in details. Okay, so this much for today. In the next class, I will go through your solution from your exercise. Okay, so till then, thank you. After.